Hello, this is Zeta Factor, and today we are looking into a nice example of applying a modular arithmetic to solving and proving or disproving the existence of solutions for Diophantine equations. We will consider this simple problem, and on this simple problem I will give you a very simple way how to work with problems like this. And very simple approach would be the following. Let's look into the problem first. We need to prove that the equation x in power of 3 plus y in power of 4 equals 7 has no solutions in integers. So before I jump into the solution, one hint that works in many cases like this is to look into the powers. In this case, it's 3 and 4, and consider the whole equation modulo some number p, where p is prime, and p minus 1 divisible by both powers. So p minus 1 divisible by 3 and by 4. In this case, this is actually a very simple methodic, and I will show you why it works in this case, but it actually works in many other cases. Maybe in some day I will give a specialized lecture explaining why this methodology works, but at this moment just remember to pick up such p prime that divides by both, or like if more than 2, all the powers in equations like this. In this case, p equals 13 works really well because p minus 1 equals 12, and it's 3 by 4. So we will consider p equals 13. So we will consider all the parts of this equation modulo 13. To do this, we need to build a table of different modulos to help us to solve the problem. So like to do it, like let's consider this thing. We have x and x cube modulo 13 we will be figuring out. We need to consider numbers from 0 to 12 to consider modulo 13. So let's quickly find those modulos. Still be 0, obviously, 1. And then let's consider. So here we're like x or y. We consider y power of 4 modulo 13. It's very easy to calculate. It's 1, 3. Okay, so now we have all this, all these modulos by 13 for both powers. Let's see how these sets look like. So first set consists of 0, 1, 8, minus 1, 5. Second set consists of 0, 1, 3, 9. So which means that x cubed plus y 4 will continue the following set, which is basically all the pairs of these sums. So it would be 0, 1, 1 plus 1, 2, minus 1, so it would be 3 plus 1, 4, of course it's 9, 8, 5, then of course 6, 5 plus 1, 5 plus 9, it will be 14, which equals 1. 8 plus 9 equals 17, which will give us 4. I think it will be also, okay, there should be 10. 6, 5. Do we have 3? Yes, we have 3. And I think that's it. Yeah, that should be it. As you can see, all the possible sums of x modulo 13 plus y, x in the power of 3 modulo 13 plus y in power of 4 modulo 13 gives us these numbers. And the thing is, there's no 7 in it, which means that sum of those never equals to 7, which means that original equation has no solution in integer. Thank you for tuning in to Zeta Factor today.